Welcome to another video interview brought to you by AIChE's ChEnected, where engineers mix it up. My name is Stephanie Orvoine-Couvrette, and I am a project associate in our program development group, and I'll be your host today. With me is Brian Korgel, who is the 2012 winner of the Professional Progress Award. Dr. Korgel is the Temple Professor #1 and Matthew Van Winkle Regents Professor of Chemical Engineering at the University of Texas at Austin. He also directs the Industry University Cooperative Research Center for Next Generation Photovoltaics. Welcome.
Great, thank you.
Dr. Korgel, the title of your talk is At Least 1,000 Times Thinner Than Human Hair, where you'll talk about nanomaterials being studied for lithium-ion batteries and photovoltaics. Can you tell us a bit about what new technologies we can expect to see with these new materials?
Yeah, well, so we've been working pretty hard for the last 15 years or so in my group on developing new synthetic methods for nanomaterials of semiconductors, metals, magnets, different types of materials that if you can control the size and the shape of these, you can elicit unique properties. And so it's been a really interesting playground to determine what those properties are. First of all, can you make these materials? And that's really the foundation of what we do. And then we do a lot of prototyping, I guess you could call it. So taking these materials, put them into different types of devices. So the two areas we've been working on quite extensively recently in the past few years are lithium-ion batteries and photovoltaic devices. And there's some really interesting properties for batteries where you could enhance the charge storage capacity of a battery by maybe up to 10 times the current levels. In the area of photovoltaics or solar cells that convert sunlight directly to electricity, there what we're trying to do is create a technology that's very inexpensive to produce, reasonable efficiencies, but also very lightweight. So essentially trying to embed solar cells in our environment sort of seamlessly. So if you could go to Home Depot and buy a carpet of solar cell carpet stuff that you would just unfurl on your roof and not have to pay huge permitting fees and that sort of thing. So those are some of the things we're trying to develop. I think the materials, they work in the lab. They need to get a bit better to be commercially viable. Those are two application areas. We've worked extensively on printed transistors for displays. Is another interesting area. There's some fascinating work being done on sensors and medical diagnostics, disease detection, and therapy also for some similar materials. And I think right now it's still a bit of a race trying to figure out which applications will pan out from these materials, but there are a lot of opportunities, so it's a pretty exciting area to work in.
It does sound exciting. So while all of these technologies sound very impressive, can we expect them to see them anytime soon? And what are some of the challenges facing their commercial use?
Yeah, I think so. There have been many startup companies started based around a lot of the technologies, not only in my lab. I've started 2 companies, and then other people in the area. And people are making runs at commercializing very new, early materials and technologies. And when you do that, you always run into some roadblocks that you weren't really expecting. So on the one hand, I think people haven't quite hit the home run with some of the really new nanomaterials that you can make and get their full potential out of them. On the other hand, there actually has been a lot of commercialization of the materials. So certain nanomaterials are used in formulations of photovoltaic devices today. There are lots of applications of different types of new nanoscale pigments and things like that, and paints. Your computer basically is a nano device. It's not made in the same way as we tend to make the materials in my group. We're really using chemistry to make new nanomaterials as opposed to etching away and building on substrates you do in the semiconductor industry for integrated circuits. But I think you'll see a lot of new things come in the next decade, and certainly in the next 2 decades, as we continue to learn how to make these new materials in large enough batches to really get to a commercial scale, and also learn their properties and what they're good for.
Well, that sounds good. And I'd like to thank you very much for sharing your thoughts with AIChE and the ChEnected community.
Great, thank you. Thanks.